Myself, Aliza Sabi, registration number 21T48. So today our lab of DSP is lab number 12, IR filter. Here is the task number 1. Given the DSP system with initial condition y of minus 2 equal to 1, y of minus 1, x of minus 1 and the input x of n. Compute the system response y of n for 20 sample using MATLAB. Following code will be used. We implement this code on MATLAB and the output of this task is here. Input signal x of n and the output signal is y of n here. So next task 2, we have given a transfer function depicting a DSP system. We have x of z is equal to z plus 1 divided by z minus 0.5. Determine the impulse response, step response, system response y of n if the input is given as x of n equal to 0.25 whole n u of n. Here is the MATLAB code for this task and the output of this task is here. Impulse response is h of n or step response is y of n and the system response y of n for x of n equal to 0.25 of whole n u of n. So the next task we have task number 3. Given the digital transfer function x of z is equal to z inverse minus 0.5 z minus 2 1 plus 1 1.2 z minus inverse plus 0.45 z minus 2. Here is the code and we run this code. We have zeros and poles in it. And the next task number 4, the following transfer function describe digital system. We have to sketch the z-plane whole zero plot and determine the stability status for the digital system. So the MATLAB of this code is here and the output of this code is whole zeros plot for h of 1 of z. So the next task of this lab is task number 5. Given a digital system y of n is equal to x of n minus 0.5 y of n minus 1 with a sampling rate of 8000 Hz, determine the frequency response. Here is the MATLAB code and the output of this code is here. Magnitude frequency response. Next task we have task number 6. Consider the following digital transfer function. We have to plot poles and zeros on the z-plane. Use the MATLAB code to plot the magnitude frequency response and the phase frequency for each transfer function. Identify the corresponding filter type. Here is the code that is used for this task. And we have to implement this code on MATLAB. And the output of this task is here, pole 0 plot of h of 2 of c. Next task number 7. For the following feedback filters, determine the location of the poles and zeros and plot the position in z-plane and compare these two results. So here is the MATLAB code for this task. Filter 1 pole 0 plot, filter 2 pole 0 plot, and the output of this task is pole 0 plot for filter 2 and pole 0 plot for filter 1.